Now, what causes the initial hormone release? The thing that causes the initial hormone release is that some cell somewhere gets a signal and it's going to stimulate that release. But why is that signal even there in the first place? And this is related to something called homeostasis. There we go. Which is your body's normal working range. And this homeostasis is constantly monitored because your body wants to stay within its normal working range. So effectively, you have some stimulus that is monitored by a sensor in your body, or some kind of, you could think of it as a receptor as well, that's just fine. And that information gets relayed to a control center. These are cells that kind of decide what to do. It can be within your brain. It doesn't have to be within your brain. Sometimes control, for instance, in your pancreas, involves these sensory cells just relaying the information to other cells within your pancreas. And in the case of your pancreas or your brain, it does not matter what. This control center releases some kind of signal to an effector. And the effector does something to address the stimulus. All right. So let's think about this in terms of your thermostat, which is probably running quite a bit right now. In the case of your thermostat, the stimulus would be it's cold. And this is going to be sensed by a receptor that actually is located in your thermostat that says the house is too cold. And that information would be interpreted by the control center to be sort of better turn the furnace on. And the effector would be the furnace, which turns on the house and heats it back up. In this case, since it heats the house, it actually reduces that stimulus. So we would call this, because of the stimulus reduction, a negative feedback loop. And it turns out all things homeostatic, it turns out that all things homeostatic are monitored and controlled by negative feedback loops, because the whole goal of a negative feedback loop is to bring things back to the norm. Now, let's imagine a different stimulus. Let's pretend now, instead of your house being too cold, that it's summertime and your house is too hot. Well, then this is going to be sensed by a similar sensor. And instead of turning the furnace on and making the house warmer, it's going to turn on the AC, and it's going to make the house colder. Still, since the effector is reducing the stimulus, so since the house is getting colder, it is less hot, this is still negative feedback. Positive feedback would occur in a different scenario. In the case of positive feedback, this would be something along the lines of, I'm going to go back to the thermostat analogy. So the stimulus is heat. The sensor senses the house is too hot. And the control center turns the furnace on, and the furnace makes heat. this is going to make this hotter. Notice the plus sign there. So basically, because it's increasing the stimulus, now this means that this is going to go around and around and around again. All right, so when are these positive feedback loops? When are these used? It turns out there are very few times in life where a positive feedback loop is used. One of them is vomiting, and you've probably had that where you get a little bit sick and you kind of, first you throw up in your mouth or whatever, and then eventually it becomes a full-on exorcist moment. Another example is childbirth. During childbirth, the stimulus is the baby's head sort of hitting the cervix, and that's sensed by sensors in the cervix and relayed to the brain, which causes oxytocin to be released. And then oxytocin causes the uterus to contract harder, and it contracts harder. It causes the child's head to hit the cervix harder. And this kind of keeps going and keeps building, and it goes from contractions basically feeling like maybe you've got a fart or something to suddenly you screaming at your significant other and telling them that you'll never sleep with them again because it hurts. So that's an example of a positive feedback loop. There are very few of these in physiology, so we tend to make a point when it's a positive feedback loop. If you have to guess, guess negative. Of course, I say that, and you know very well that I'll probably throw a positive feedback loop to you on an exam and want you to explain why it's positive. So let's think of this in an endocrine sense. In an endocrine sense, we can think of blood sugar. And let's think you've just eaten, so your blood sugar, your blood glucose, is high. What's going to happen is that this information is going to get relayed to cells within your pancreas. It's going to go to the beta cells, and the beta cells are going to cause a release of insulin. And that insulin is going to cause glucose to get stored. And it gets stored in your fat, it gets stored in your muscles, and we store it predominantly in our liver as a molecule called glycogen. All right, so that's what happens if your blood sugar gets high. What happens if your blood sugar gets low? I'm going to actually just draw this over this way. That's sensed by alpha cells in the pancreas, and it causes the release of a different hormone. This one's called glucagon. And what glucagon does is it breaks the glycogen in the liver into glucose. And then that brings that blood sugar back up. It's a negative feedback because it's reducing the stimulus. It's surprisingly easy to screw that up. All right, so that's going to bring the blood sugar back up. So this is basically how this is going to work within your endocrine system, and it's happening all the time, and you have about 1 million stimuli that are constantly being monitored without your knowing it. Don't go all tinfoil hat on me. These are things like your pressure on your vessels and stuff that you really don't want to monitor anyway.